Okay, our next discussion would be factoring polynomials. Factoring means the reverse of what we have done in multiplication. So for instance, if you are asked to find the greatest common factor of 10x squared plus 5x squared, find the GCF. So you are going to ask yourself, what is the greatest common factor between 10 and 5? It is 5, so you take 5 out. And then you're going to go ahead, what is the greatest common factor between x cubed and x squared? Always choose the one with the smaller degree or the smallest degree. So it is 5x squared. Then you open the parentheses. If you divide 10 by 5, you get 2. X to the third divided by x to the second is x, plus 5 divided by 5 is 1, x squared divided by x squared is 1, and 2x plus 1. Now, look, you cannot factor 2x plus 1. Meaning what? This is prime. Once you take the greatest common factor, what we end up is a prime, meaning what? You cannot factor any further. That's what we mean by factoring polynomials. Bringing it back to where it was. So, meaning what? If you are going to multiply 5x squared times 2x is 10x cubed, and all the way. Okay. So, let me do some exercises on this. Suppose you have 18x cubed plus 27x squared. Again, let's try to find the greatest common factor between 18 and 27. And if you go ahead and search for that, you're going to end up with 9. Then between x cubed and x squared, it is x squared. Open the parentheses, 18 divided by 9 is 2. X to the third divided by x to the second is x. And 27 divided by 9 is 3. X to the second is cancelled out. As you can see, 2x plus 3 is a prime, meaning what? You cannot factor it anymore. Okay. You could also see this kind of okay. So you can see this kind of polynomials, and then you are asked to find the factors. Look, x plus 3 is popping out twice on both sides of the border. So one of the factors should be x plus 3. Now, if you take x plus 3 out, because you already have, what you have on the border is x squared plus 5. Then you can combine these two together, x squared plus 5. Again, make sure your final answer, you cannot factor this anymore, you cannot factor x plus 3 anymore, and then you're going to leave it like this. All right. Now there is something called factoring by grouping. This happens when you have 4 terms, factoring by grouping. And this is very straightforward. So let's say you have x cubed plus 4x squared plus 3x plus 12. Now you have 4 terms. This is, when you do this, it is a trial and error. You can always shift the variable so that you can have factors that correspond to the question. So meaning what? Let me group this, x cubed plus 4x squared, and then 3x plus 12. And let me try to find the greatest common factor between these two. Between x cubed and x squared, the greatest common factor is x squared. If I open the parentheses, then I would end up with x plus 4. Now, when I do factoring by grouping, if I get another x plus 4 in here, then I know that I'm factoring correctly. But if I get a different answer, then I'm not factoring it correctly. So let me go ahead and do what is the greatest common factor between 3x and 12? It is 3. And then x plus 4 pops out again. I know I have factored this the right way. So one of my factors is x plus 4. If I take x plus 4 out, what is left is x squared plus 3. Make sure that this is not factorable anymore, and we're done. Okay, that's an example of factoring by grouping. And then you have seen this again in 096 or 095, factoring trinomials. You know pretty well, a trinomial has 3 terms. Let's say ax squared plus bx plus c. And I think this is a refresher. So to find the factors, you have to find what? The product would be a times c. Meaning 2 numbers multiplied will give me a times c, whatever that number is. And the sum is what? The sum is the middle term, the sum is b. Okay, so let's use with one example. Let's try. X squared plus 6x plus 8. Right? Now the product of this polynomial, or it itself is the product, but the product of the 2 numbers that I'm looking for. There is 1 in here. 1 times 8 is 8. And the sum of those 2 numbers that I'm looking in order to factor has to be 6. So you have to match these 2 concepts. And you can find that the product of the 2 numbers multiplied, which give me 8, could be 4 times 2. And 4 plus 2 will give me 6. So I have found the 2 factors. So I'm going to go ahead. I can rewrite as 4 terms, or I can simply write the factors. I'm just going to give you both sides. You can either do, it's a long way, you can either do this, x squared plus 4x plus 2x plus 8. What you did is 6x, you split them into 4 into the 2 factors. So that is pretty much. This explains why we end up with x plus 4 and x plus 2. So you group them together, find the greatest common factor between x squared and 4x, it is x plus 4, and then plus, between 2x and 8 it is 2, x plus 4, okay? And then you go ahead and write x plus 4 is one of the factors, and the other one is x plus 2, okay? We can do that by grouping, or you can simply go ahead and once you find the factors, you can write them. But you have to be careful. If a is a number other than 1, then we have to be very cautious. Okay, so probably I should do that. Just to make sure that we understood the concept. So we have 8x squared minus 10x minus 3. Mind you, now the leading coefficient has other number other than 1, right? So the product would be what? 8 times negative 3 is negative 24, and the sum is negative 10, right? So we are going to find 2 numbers. If we multiply, we're going to get negative 24, and if we add negative 10. Make sure of the signs. If the product is a negative number, then one of them has to be positive and the other one has to be negative, right? And if the sum is negative, then the larger number has to be negative. So this one tells me the sign of the larger number. This tells me the product is negative. And one of them has to be positive. So if you go ahead and browse all the possible factors of negative 24, you're going to end up with negative 12 and 2, because negative 12 times 2 is negative 24, and negative 12 plus 2 is negative 10. At this juncture, I would advise you to use the factoring by grouping. So let's rewrite this as 8x squared. So instead of writing minus 10x, I'm going to write minus 12x plus 2x minus 3. So minus 10x means minus 12x plus 2x. So I'm not changing anything. Then let me go ahead and do this. Go ahead and find the greatest common factor between 8 and 12. It is 4. Between x squared and x, it is x. So what is left is what? 2x minus 3 plus. Now, my question would be, what is the greatest common factor between 2x and 3? Don't say 0. Always 1 is a common factor, the greatest common factor. And then open a parenthesis, 2x minus 3. I have 2x minus 3 and 2x minus 3, which is one of my factors. Once I get rid of that, then I have 4x plus 1, and then we're done. That is factoring trinomial with coefficient other than 1. Okay. So that takes care. Now, special factors. Special factors. You remember when we were talking about a plus b, a minus b, that is a squared minus b squared. It is a product. If I want to factor this, then I have to go back, meaning what? The two factors of a squared minus b is a plus b and a minus b. So that's what we are doing. We are going backwards from what we did earlier. So if you have x squared minus 4, probably write it in this way, x squared minus 2 squared. That's what it means. So if the product is squared minus b squared, then it has to be what? So you're going to write x and 2, x and 2, in the same way that corresponds. Then one of them has to be plus, and the other one has to be minus, x plus 2 and x minus 2. I know, you know about this. So. Okay. Okay. I want you to misbehave. Okay. Let me do another one. 81 x squared minus 49. And this is also an example of the difference of two squares. Just to make it easier, find 81. 81 is a perfect square. So you can rewrite this. Instead of 81, you can write 9x, the entire thing squared. Okay? 9 squared, x squared. And minus what? 7 squared. Then you would write what? This is 9x, 7, 9x, 7. One of them is plus, one of them is minus, and then we're done. Another example of this. Now, this is x to the 4th minus 81. So, it's not written in the form of the difference of two squares, because if we are talking about the difference of two squares, it has to be squared, not to the 4th power. But we can change this. write this as x squared squared using the power rule. Then you would have what? Minus 9 squared. Now it becomes what? The difference of two squares. So use the formula. So this would be x squared 9 and then another x squared and 9. Now you're going to put one of them is plus, one of them is minus. This x squared plus 9 we cannot factor it because there is no such thing called the sum of two squares in real numbers. But if you look at the second factor, we can factor it again because this is another instance of the difference of two squares. So you're going to rewrite this. This is the same as saying x squared minus 3 squared. Right? Now you know that you can factor them. So one of them is x and 3. The other one is also x and 3. One of them is plus. One of them is minus. Now you're going to bring the one which you cannot factor, x squared plus 9. This would be your final answer. Okay. Okay. Now, a cubed plus b cubed and a cubed minus b cubed. This is another special factoring. The first one is the sum of two cubes, and the second one is the sum of the difference of two cubes. And we're going to use the formula. You have seen that this in 095. So if I want to factor a cubed plus b cubed, it is a plus b times a squared minus ab plus b squared. Meaning what? If you multiply this by this, you can go ahead just to prove this, you would end up with a cubed plus b cubed. This is the difference of two cubes. So you would have a minus b, and then you have a squared plus ab plus b squared. So all you need to do is just know this formula and plug in the questions that you are going to have. So let's start with x cubed plus 8. This is the sum of two cubes. Then rewrite this as x cubed plus 2 cubed. And then use the formula, the sum of two cubes. So this is your a and this is your b. Okay. So if you do that, then you end up with x plus 2, and then you have x squared minus x 2x, right? Because x times 2 is 2x, plus b squared is 2 squared, which would give you 4, right? So you end up with x squared minus 2x plus 4, you're done. Okay. Again, to prove, just multiply x plus 2 by this, you would end up with x cubed plus 8. Okay, that's the idea behind it. Probably let me do some more. Suppose you have now 64x cubed minus 125. This is the difference of two cubes. So we might as well write in the form of cubes. So 64 is the cube of 4. 4 times 4 times 4. So you can rewrite this as 4x, the entire thing cubed. And 125 is 5 cubed. Once you write it this way, let's go ahead and apply the formula. So in fact, we are doing the second one, so you would end up with 4x minus 5, the first factor. And if we go to the second one, you would end up with 4x, the entire thing squared, plus a times b would be 4x times 5, and b squared is plus 5 squared. So it's pretty much a straightforward concept. So we're going to do this for x minus 5. 4x squared would give you 16x squared. If you multiply the middle term, you would end up with 20x and plus 25, and then we're done. Okay. Now, so that takes care of the sum and the difference of cubes. So, now let me look at these factors. 2x cubed plus 8x squared plus 8x. So you're gonna do probably different factoring for one particular expression. So the first thing that we need to do is look, x 288 and x is everywhere. So I can automatically look for the greatest common factor between these two. So if you can see this, it is 2x. 2 is the greatest common factor for the numbers, and x is. And then you end up with x squared plus 4x plus 4. Look at the middle term, this x squared plus 4x plus 4. This is a perfect square, because if you look at the product and sum, right, two numbers multiplied will give us 4, and added will give us 4. They are 2 and 2. In fact, both of them are positive. So this is 2x. Then you would end up with x plus 2 times x plus 2. Or, if you wish, you could rewrite this as x plus 2 squared. Okay. Okay. I think that takes care of this session, and I'll see you in the next one.